We're talking about trigonometric identities. Remember that an equation is the statement that two mathematical equations or expressions are equal. So we can show this by solving. So we have x plus 2 is equal to 5. If I subtract 2 from both sides, I get x equals to 3. So when x equals 3, this equation is true and both sides are equal. Can it be true for any other values of x? Well, no, because only 3 will work for that solution. But an identity is an equation that's true for all values of the variables. So if we have x plus 1 squared equal to x squared plus 2x plus 1, if we separate that out and put x plus 1 times x plus 1, and we distribute or FOIL, we get x squared plus 2x plus 1 is equal to x squared plus 2x plus 1. Well, both sides are equal to each other, so this is what we call an identity. Well, we have some of the things already that we can use. Trig identities are identities involving trig expressions. So how do you know if an equation is an identity without trying all the solutions? Well, we're going to show that one side is equal to the other side, and we'll do this by transforming or simplifying one side into the other side using identities we already have. So let's go look at whether or not something's an identity. We'll talk about a couple of things and then we'll try it. So we have some fundamental identities that we know already. We've got these here. Our reciprocal identities, we have the Pythagorean identities, and we have the even and odd identities. Remember, cosine and secant are our even functions, where the negative sign will be absorbed into it when we plug in a negative x. But the sine and tangent functions, the negative sign will come to the outside. Identities are going to enable us to write the same expression in different ways. So let's go look at whether or not something is an identity. So if we have sine x plus cosine x equal to 1. Now this is not squared, it's just sine and cosine. If we try it for x is equal to pi over 2, we have the sine of pi over 2 plus the cosine of pi over 2. We want to know if that equals 1. Well, knowing our trig functions from our unit circle, we know that the sine of pi over 2 is equal to 1, and the cosine pi over 2 would be equal to 0. Well, 1 plus 0 is 1. 1 equals 1. It is true. All right, let's try it this time. Let's try pi over 4. So if we do x is equal to pi over 4, we would have the sine of pi over 4 plus the cosine of pi over 4 is equal to 1. Well, sine of pi over 4 is square root of 2 over 2. Cosine of pi over 2 is pi over 4 is square root of 2 over 2. Well, that gets us 2 square roots of 2 over 2 when we add them. Well, the 2's will cancel. We end up with the square root of 2 equals to 1. This does not work. It is false, so this is not an identity. So this is where we get into the point of not wanting to try all of the different examples that are out there to see. You know, you've got to find like one counterexample in order for this to not be true. So we are going to convert the different identities that we have. Some of the Pythagorean identities, sometimes we're going to use those to solve for sine squared or cosine squared in a particular situation. But here's some things that we're going to do. So we are going to start with one side, transform it into the other side. It's usually easier to start with more complicated side and transform it to the simpler side. We'll use the algebra tools and techniques that are known in identities to change the side you started with. So we'll have common denominators. We can factor, do difference of squares, do distribution, and use the identities that we've already talked about to simplify the expressions. The first thing that you'll want to do is convert each fraction to sine and cosine, or sorry, not fraction, but function, and that can be helpful to see how we're going to manipulate the problem. When we're actually verifying a trig equation is an identity, transfer one side of the equation into the other. We're not going to perform the same side to both operations like we would have done with algebra. We'll just work on one side at a time because you want the left side to equal the right side. And if both sides are complicated, you want to simplify each side to see if they are equal. So those are the skills we're going to use. Let's go look at some problems. So the first thing we're going to do is simplify cosine t plus tangent t times sine t. So we're going to rewrite it in terms of sine and cosine. This is not an equation, it's just an expression because it doesn't have an equal sign. So we're just going to take it from there and just take care of it. We don't have a left or a right-hand side. First thing we want to do is rewrite it in terms of sine and cosine. So we have cosine t. Tangent will be sine t over cosine t, and then multiply by sine t. That'll get us cosine t plus sine over, or times sine. You can always put it over 1 to help you see it. Sine times sine will get us sine squared t over cosine t. Now this cosine t is over 1. Again, that can help you see what you're doing. We've got to get a common denominator. The common denominator would be cosine t. So here we're going to take our cosine t and multiply it by cosine t over cosine t in order to get it with that common denominator. So that's still over 1. So we multiply by 1 to get there. And this isn't going to change because we're just getting a common denominator. So now we have cosine times cosine will get us cosine squared t over cosine t plus sine squared t over cosine t. Well, now that we have a common denominator, we can add them. So we have cosine squared t plus sine squared t over cosine t. Well, this is our Pythagorean identity. It's equal to 1. So 1 over cosine t will get us secant t. So this complicated thing we started with is just secant t. And we're going to do another example similar to this, just using our skills that we have. So we are going to simplify another expression. So for this one, we are simplifying sine theta over cosine theta plus cosine theta over 1 plus sine theta. So again, we've got to have a common denominator. Everything's already written in terms of sine and cosine, so we're just going straight for the denominator. Our denominator will be these two being multiplied, so we'll have cosine theta times 1 plus sine theta plus, over here again, we'll still have the same denominator. Now on the top, we already had sine theta, so we're going to write that. We have the cosine theta, but we need to multiply by the 1 plus sine theta, because again, we multiply by 1, so it'll be 1 plus sine theta. So we had cosine, or sine over cosine, and we needed the 1 plus sine theta, so we multiplied by 1. And top to the bottom. What you do to the bottom, you do to the top, or what you do to the denominator, you do to the numerator. Either way you want to look at it. All right, so over here, we already had the 1 plus sine theta, so we ended up doing a cosine. So we have a cosine to start with, and then we multiplied the denominator by cosine, so we also have to do the top by cosine. All right, so now we have a common denominator. So let's go ahead and distribute and put it over one fraction, or make it into one fraction, one denominator. So sine theta times 1 will get me sine theta. Sine theta times sine theta will get me plus sine squared theta. Cosine theta times cosine theta gets me cosine squared theta all over cosine theta times 1 plus sine theta. Now, things you need to start recognizing, if we have sine squared plus cosine squared, that is a Pythagorean identity and it is equal to 1. So now we have sine theta plus 1 over cosine theta times 1 plus sine theta. Notice I did not distribute to the denominator. I don't do the distribution to the denominator until the very end because you never know if you're going to be able to cancel some stuff out first. All right, so sine theta plus 1 is the same thing as 1 plus sine theta, so those will cancel, leave me with a 1 on top. I end up with 1 over cosine theta, which is equal to secant theta. So again, it's simplified down to secant. It will not always do that, but sometimes you'll have things that are completely different looking, but they end up being the same thing. So for this next example, you can stop once I write it out, you can stop it and the video for a second and try it and see if you can get it, or you can keep on watching. But in case you want to practice one to see if you can figure it out. Usually if we were in class, I would have you guys try this one and then we'll go over it. All right, so we have sine u plus tangent u times cosine u. So this would be the time to stop it and try it on your own. And then come back and find out what I've done with it. All right, so we're back. And I'm going to rewrite this in terms of sine u and cosine u. So we have sine u plus cotangent will be cosine u over sine u times cosine u. Let me do parentheses there. All right, this would get us sine u plus cosine times cosine will get us cosine squared u over sine u. Again, that's over 1. Sometimes that will help us to see what we've got. We've got to get a common denominator. This time our denominator will be sine u. So we have the first sine u over 1. We're going to multiply by 1, and 1 this time will be sine u over sine u, plus cosine squared u over sine u. Multiplying those out, we'll get sine squared u over sine u, plus cosine squared u over sine u. We've got a common denominator, so we'll combine our numerators. So sine squared u plus cosine squared u over sine u. And again, recognizing that this is our Pythagorean identity of equal to 1, we'll end up with 1 over sine u, and 1 over sine u is equal to cosecant u. So cosecant u this time. All right, so now we're going to go look at, those were all trig expressions. We're going to go look at equations at this time, and instead of simplifying, we are going to verify. All right, so we are going to verify that cosine theta times secant theta minus cosine theta is equal to sine squared theta. So we have two sides of the equation, and this is where we're going to do our left hand and right hand sides. And we're going to pick the more complicated side, which is this side. This is already written in sine and cosine. It is just sine, but just pointing out. So we don't have to do anything over here. We're going to take our left hand side and verify that it will equal this side. So the left hand side we're going to rewrite. So we have our cosine theta times secant theta minus cosine theta. Now we'll write it in terms of cosine and sine. So cosine theta and secant theta goes with is reciprocal identity of cosine. So it'll be 1 over cosine theta minus cosine theta. Now let's distribute. So we'll have cosine theta times 1 over cosine theta Cosine theta times cosine theta will get us cosine squared theta. All right. So now cosine theta over cosine theta is equal to 1 minus our cosine squared theta. Well, this is the same thing as sine squared theta, which is equal to our right-hand side, and we got to check on that. So let me show you why, because you're like, if you get it, great. If not, you need to know why. We have our Pythagorean identity, that is sine squared theta plus cosine squared theta equal to 1. If I subtract my cosine squared theta from both sides, I have sine squared theta equal to 1 minus cosine squared theta. So that's where I can use my Pythagorean identity to show that this is equal to sine squared theta. All right, so here's one for you to try. So I'm going to get it started, and then you can stop the video again and try it on your own. So we are going to verify that sine x times cosecant x minus sine x is equal to cosine squared x. All right, so go try it on your own and then come back. All right, so we're back, and hopefully you have been able to simplify this and verify that it is equal to that. We are going to start again with the left-hand side because it is more complicated. So I will rewrite this one. And I'm going to rewrite it now in terms of sine and cosine. So we have sine x. Cosecant x is the reciprocal identity of sine. So we have 1 over sine x minus our sine x. Distributing our sine x, we'll get sine x over sine x minus sine squared x. Well, that's 1 minus sine squared x. And this goes similar to what we did a minute ago. So instead of moving the cosine, I could move the sine over and get 1 minus sine squared x, which would be equal to cosine squared x, which is equal to our right-hand side. So we have verified that one side is equal to the other. Sometimes when we're doing these, it's easier to do the verifications than it is to do the simplification because you know where you're going to. All right, let's go do another problem. So here we are going to verify that 2 tangent x secant x is equal to 1 over 1 minus sine x minus 1 over 1 plus sine x. So here we're looking at more complicated sides. Sometimes the more complicated side is when you have fractions. So we are going to simplify the right-hand side to equal the left hand, but I like to know what my left hand looks like, so I am going to rewrite this side just in terms of sine and cosine before I get started. So tangent is sine over cosine, and then secant is 1 over cosine. So that way I have an idea what I need this to come and be like. If you don't rewrite it, you don't have an idea kind of where you're going. I can see now, since I've rewritten this side, I'm going to need a common denominator of cosine to get there. But we're not starting on this side, we're starting on this one. Alrighty, so we have the right-hand side is equal to 1 over 1 minus sine x minus 1 over 1 plus sine x. Our common denominator for this, we would end up with getting that times that. So we would have 1 minus sine x times 1 plus sine x minus 1 minus sine x times 1 plus sine x. So that's going to be our common denominator. So on this one, multiplying by 1 doesn't change anything. So that I had this common or this denominator, I multiplied by 1 plus sine x. You can put the 1 up there, but it won't change anything because it's just being multiplied by 1. Same thing will happen on this side, except I have the 1 plus sine x, so I need to multiply by the 1 minus sine x. Again, the 1 multiplied out there won't change anything. Alrighty, so now I have 1 plus sine x minus 1 minus times a negative sine x gets me plus sine x all over my common denominator of 1 minus sine x times 1 plus sine x. So on the top, my 1's will cancel, and I have sine x plus sine x will get me 2 sine x. Now, I can see that my top is not going to simplify down until with any of this. So this is where I'm going to look at my denominator and go, this is the difference of squares. Same thing times itself. With the difference of squares, the middle terms cancel when we FOIL out or distribute. So we'll have 1 times 1, and then sine x times sine x would be sine squared x, so minus sine squared x. And we know that 1 minus sine squared x would be equal to cosine squared x. So 2 times sine x over cosine squared x. And this would be the point where it's hard to see where you're going, except, remember we did this over here. I know we're going to have a 2. I need a sine over cosine and a 1 over cosine. And that's why I write the other side already in terms of sine and cosine, so I know where to go from here. So I can break this up. I'll have the 2. I'll put the sine x over cosine x, and then 1 over cosine x. So the top I didn't do a whole lot to, but the bottom, cosine squared, I can rewrite as cosine times cosine. And then put a 1 on top of it, so I get the 1 over cosine. This now becomes 2. Sine over cosine is tangent x, and 1 over cosine will get me secant x. And this equals our left-hand side. So we showed that one side equaled the other. Now the other thing you can see with any of these is if we go backwards, we could prove it's that one. But I want you to see that if I take this one backwards, it's a little bit harder to go that way. You'd have to transform that, combine that together, understand that cosine squared x would be equal to 1 minus sine squared x, and then take that and make it the difference of squares factoring. And then this is where it would get complicated. Where do you get the 2 sine x to become your top? So that's why you want to pick the side that's harder to do, because it's going to be harder to go the other way. But on any of the problems we've done so far, so we could look at this one, take cosine squared if we had taken the right hand side instead of the left hand, change it into that, but then again you have to figure out that 1 is going to be that, and then you'd have to take this and factor out a sine to get to there, and then change it to the cosecant. So you can do it with any of them. You can see how it would be to go the other way, but when you pick the easier side, it's more complicated to simplify it out into something on the other side. But it gives you an idea of what you could do instead. All right, so let's go do another problem. So we are going to verify that cosine u over 1 minus sine u is equal to secant u plus tangent u. So again, this is probably the more complicated side because it has a fraction. It's not always going to be the side, but that's the one we're going to do. But I want to rewrite this so I know what I'm looking for. Secant u would be 1 over cosine u plus tangent u would be sine u over cosine u. So let's take our left-hand side, which is equal to cosine u over 1 minus sine u. It's already written in terms of sine and cosine, so that's not going to help me at all. But I know that my denominator has to get to be cosine. Well, the only way I can clear out the signs here and simplify this denominator is to multiply by the denominator part. That would make that the difference of squares. So I'm going to multiply by 1 plus sine u. Because then my denominator will become 1 sine u times 1 plus sine u. All right, so here we'll have 1 minus sine u times 1 plus sine u. And on the top, we have cosine u times 1 plus sine u. Well, 1 minus sine u times 1 plus sine u is difference of squares, so we have 1 minus sine squared u on our bottom, and on the top, we're going to leave the top by itself. So we'll have cosine u times 1 plus sine u still on our top. All right, 1 minus sine squared u will get us cosine squared u on the bottom. On the top, we still have cosine u times 1 plus sine u. Well, this cosine squared u and cosine u, I can cancel out the cosine u with the squared part, and that will get me 1 plus sine u over cosine u. Now I can split my fraction and get 1 over cosine u plus sine u over cosine u. Oh, that looks just like that, written in terms of sine and cosine. So when you have a fraction, you can split it and put it over the denominator. 1 over cosine u will get us secant u. Sine u over cosine u will get us tangent u. And this equals our right-hand side. And then we'll check. All right. So let's go look at another example. So we're going to verify something, and sometimes both sides are complicated. Neither one is an easier side than the other. So we are going to verify that 1 plus cosine theta over cosine theta is equal to tangent squared theta over secant theta minus 1. Now, they're both complicated. They both have a fraction. So what we're going to do is solve the left-hand side and solve the right-hand side and see if we can get them simplified down to equal each other. So here's our solution. If we take our left-hand side, which is equal to 1 plus cosine theta over cosine theta, I'm going to separate the fraction like we did on the last one. So I'll have 1 over cosine theta plus cosine theta over cosine theta. Well, 1 over cosine theta is secant theta, and cosine over cosine is 1, so I get secant theta plus 1. All right, that's as simplified as I can go, so now let's go try the right-hand side. So the right-hand side is tangent squared theta over secant theta plus, minus 1. That's a minus, not a plus. So the bottom is secant theta minus 1. The top is tangent squared theta. Now, tangent squared theta, if I take this Pythagorean identity and I take tangent squared theta, if I subtract the 1, I get secant theta minus 1 is equal to tangent squared theta. So I'm going to do that on this one. So it'll be secant squared theta minus 1. This is the difference of squares on the top, so we'll have secant theta minus 1 times secant theta plus 1 all over secant theta minus 1. So this is one of those where we did not change everything into sine and cosine. Now the secant thetas minus 1s will cancel, and we end up with secant theta plus 1. Well, I can say that the left-hand side equals the right-hand side at this point, so I have verified that they are equivalent. Okay, so sometimes we're going to have to do things a little bit differently, just depending on how complicated it is. All right, let's go look at another problem. So let's verify that sine theta over tangent theta is equal to cosine theta. Well, our left-hand side is the more complicated, so left-hand side is equal to sine theta over tangent theta. Rewriting that in terms of sine and cosine, we get sine theta divided by sine theta over cosine theta. Well, remember, we don't divide by fractions, we multiply by reciprocals. So we have sine theta times, and we'll do parentheses, the reciprocal of the bottom, so cosine theta over sine theta. Remember that sine theta is over 1, so our sine thetas will cancel, and we end up with cosine theta, which is equal to our right-hand side. So some of them are going to go really quick. You just got to pay attention to what you're doing. All right, so here's one that you can try. So again, you can work it, and then you can stop the video while you do it. So let's verify that cosine x over cotangent x is equal to sine x. So stop the video if you want to and try it and come back. All right, so welcome back. So we are going to again do our left-hand side because it's the more complicated. So the left-hand side is equal to cosine x over cotangent x. And cotangent x is going to be cosine x over sine x. We don't divide by fractions. We multiply by reciprocals. So we'll have cosine x times sine x over cosine x. The cosine x's will cancel, and we end up with sine x, which is equal to our right-hand side. All righty, let's go look at another example. So we are again doing some verification. So we're verifying. And we are looking at cotangent x, secant x, over cosecant x. And we want to prove it's equal to 1. All right, so let's do our left-hand side. Because 1 is, there's not much we could do with that. We'd have to figure out how to even go. So left-hand side's the one we're going to work. So we have cotangent x secant x over cosecant x. First thing we're going to do is write everything in terms of sine and cosine. So cotangent will be cosine over sine, and then secant is 1 over cosine, and on the bottom, cosecant is going to be 1 over sine. So the first thing you want to do is simplify what you can. The cosines will cancel up here, so I end up with 1 over sine x divided by 1 over sine x. Well, this is the exact thing over itself, so in that case you can go straight to the answer of 1. If you want to, also if you wanted to prove it, you could multiply by the reciprocal and they'll still cancel out. But if it's the same exact thing over itself, that equals 1. All right, the next thing we're going to look at is some trig substitution. This will be the last thing we look at. So trig substitution. So we're going to sub sine theta is equal to x in the square root of 1 minus x squared. And we are given that our theta is between 0 and pi over 2. So we're going to sub in sine theta into here. So that means we're going to have the square root of 1 minus sine squared theta. Well, 1 minus sine squared theta is equal to the square root of cosine squared theta. And the square root of cosine squared is going to be equal to cosine theta. Now, we are in 0 to pi over 2, which is quadrant 1. So cosine has to be positive because we are in that quadrant for all the values that are given. We know that cosine theta is going to be positive because of the quadrant it's in between the 0 and pi over 2. So have some fun. Practice, practice, practice how you're going to get these done. You've got to practice your trig identities to know them, to make it easier for you. Do your homework.